Starting the class, children. So today we are going to do pH of weak acids and weak bases. So you already know the list of your weak acids and weak bases. So if you remember, for the weak acids, we already know strong acids. And then I gave you one more magic rule that all carbon containing acids are all carbon containing. Carbon and phosphorus containing. P element, C element, P element. They are weak acids. This we have to remember. And all acids which are ending with us in the nomenclature, they are ending with us. Like the polyatomic ions ending with ite. When you make the acid of them, then they will end with us. So all of them which are ending with us are weak acids. Like HNO2, nitrous acid, H2SO3, sulfurous acid. So these are popular weak acids. These one, they end with us. All carbon and phosphorus containing acids are weak acids. So keep reviewing all these rules so that you should not do error in the exam, or you should not get worried whether this acid given to me is weak or strong. Okay. And one more thing, whenever there is a question of weak acid, like this is a question of weak acid. You can see this acid. Those who have not written this rule, please write down. This is the rule for the weak acids. One more rule. One is this. Second is this. Third is that in the non-oxo acid, only HI, HBr, HCl, only these are strong. Only these are strong acid. Rest all are weak. Rest all are weak. So this I'm telling you, I think from last 3-4 classes. So make a list, keep reviewing it. And another important thing is that they will give you the Ka and Kb values. And do you know weak bases? Who all are weak bases? Except first group hydroxides, because they are strong. Sodium hydroxide, potassium hydroxide. No, not second, Shrihan. Except first group hydroxides and calcium 2 plus, barium 2 plus. You are not going to take complete group 2, and strontium 2 plus hydroxides, because these we have understood that they are strong. They are strong bases. Rest all, whatever else is there, they all are weak bases. Like generally you'd be dealing with NH3. NH3 is a weak base that you can memorize. NH3 is a weak base. CH3NH2, C2H5NH2. Then there is this molecule you can see also, but they will tell you C6H, C6H5N. All these are weak bases. So you can say that the carbon containing with nitrogen. So generally nitrogen compounds in organic chemistry of this type, we call them as amines. So they are bases. So I have seen that in AP they are taking these examples. So they will write down it's a base. And if they are writing a base, then you can put them in the category of weak bases because you know that strong bases are these only strong bases. Okay. So whenever they are talking about weak acids and weak bases, they are going to give you the Ka and Kb values. Okay. So what do you know about weak acids and weak bases? That their Ka, Kb will be given to you. They are not fully dissociated. What else? They are not fully dissociated. This I'm talking about weak acids and weak bases. What are the things which you have to keep in mind during the examination? Okay, this is a question of weak acid, not fully dissociated. And their Ka and Kb value must be given to us. If it is not given, then you are calculating. Something is there. You need not to memorize them. Don't memorize. You can compare the magnitude of Ka and Kb. And another important thing that there is equilibrium. You are going to work with equilibrium now. Unit 7. Equilibrium. You are going to make rice table. Here we are going to make rice table. Yesterday we were making only initial and final, right? Here we are making a rice table. So, and from the rice table, you will calculate the concentration of H plus. And from the concentration of H plus, if you are dealing with a base, you'll calculate OH minus concentration. And from there, you can work out pH. Like in case of OH minus, you can work out POH. And from POH, you can go for pH. So today we are going to focus on this. How to calculate pH, POH, of means the questions which are based on weak acids and weak bases. In some questions, we'll be calculating the pH. In some questions, we'll be calculating the Ka value or Kb value. Calculating, we are not memorizing them, calculating. In some questions, they will give you everything and they will ask you the degree of dissociation, how much acid is dissociated. So that's how we are going to work on this part of the unit. Ready, children? Before I start, let me pick up the value of, there was a table here, right? Okay, 1 second, I'm searching the table. I remember yesterday I was showing you one table. Don't know where it has gone. Okay, fine. So the table somehow I'm unable to search. So I'm giving you Ka values. Ka value for this acid. You know what is Ka? What is Ka, children? What is Ka? Who is going to type the meaning of Ka? Yes, I think I'm audible. So what is Ka? We have done it so many times. Yes, it is acid dissociation constant. If the magnitude of this constant, acid dissociation constant is high, if the magnitude is high, what does it mean? It is a stronger acid or weaker acid? If the Ka value is high, then it means it's a stronger acid. Very good. What happens to the concentration of H plus? Concentration of H plus will be high. What happens to pH? pH is low. Now compare this acid A and B. Which one do you think is stronger acid? Which acid is stronger? Mhm. A is stronger. So they are asking me to calculate the pH. So when I'm going to calculate the pH, which acid will get less pH? Shrihan, A, not B. Lasya, Shrihan, Lasya. Are you clear about it, Lasya? Okay, good. Fine. So now these are weak acids. So there is an equilibrium. They are not fully dissociated. Now the first challenge is writing the dissociation of the acid and bases in water. Many children, they have the problem in writing the dissociation. So in the acids, because there is hydrogen here, you just write AQ, don't write water, and put the equilibrium sign like this. There is no need of writing water. In the base, we need to write water, base, okay? But here in the acid, you can just represent water as AQ. Now, can you complete the equation? Equilibrium is there. I'm writing the reaction first, the dissociation of the acid in water. So I'm going to get H plus because it's an acid. Acid is proton donor, is donating proton to the water, plus NO2 minus. This is the conjugate base. You're removing one hydrogen, so you're getting one negative here. This is the reaction. Then you make initial, change, equilibrium, and let's fill the table. Initial. What are the major species? That also we have to see. We'll see in the equilibrium. Like earlier, we were looking at the final, but now we'll see in the equilibrium. 0.250 molar solution. This is initial. H plus is 0. NO2 minus is 0. Change. What is change? Minus X, minus X, minus X. I think I'm wrong. Can you correct me, children? Yes. Plus X plus X. Yes. Yes. Thank you. Equilibrium. Equilibrium will be 0.250 minus X, X, and X. Is this species 0 finally? This is final. Equilibrium is final, right? Now, what are the major species finally? What are the major species? List the major species from the final situation. Major. Yes, please. What are the major species? H plus, NO2 minus. Yes, Vinaya, very good. HNO2, NH2O. Perfect answer. So these are the major species. Now, what is Ka? Ka is the concentration of H plus. K is the dissociation constant, the equilibrium constant. NO2 minus over HNO2. Plug in the values. It is x squared over 0.250 minus x. Now, you can do approximation because children are suffering with this, that how to solve a quadratic equation because you people are unable to work out with your calculator. So my advice is do not waste time in the examination. Do approximation. And we can check the validity of the approximation. No, Dhruv, no one is ready to make. And somehow I'm trying to purchase the this calculator so that I can see how to use it and can guide you. but I don't think it's available in the India. So we are searching if we can get it in India. But I don't know why you people are unable to make out from the videos uploaded by the company. There are so many videos online, and even the company people can help you because AP is asking you to use graphing calculator. So it's a kind of real benefit. You are not going to struggle with any equation. You just plug in equation, you get the answer. No, Shrihan, you have to. I think my one of my student, she's not in the group. She's my very old student, 5 year old. She was telling me that they have to put math mode. There is an option math mode. If you put math mode, then you'll get the option of plugging in the equation. Yes, Dhruv, it's very expensive and it's no use to me. That's the problem. But it's okay. I'm ready to spend money, but I should get the because I purchase something and then you people are using something else, then again it's a problem. So that is the reason I'm slightly not interested in purchasing it. But if you, I'll see that what can be done. But why don't you try to learn it from your school teacher, mathematics teacher? She can also help you. Take your calculator there, ask her to help you. Okay, so right now because we are struggling, so I'm going to do approximation and I'll show you how to check the validity of the approximation. You're learning a new thing now. So I'm doing approximation here, only here, not here, okay? Where there is minus x and plus x. So on approximation, what are we getting? 0.250. So this minus x I can remove. I'm assuming that x is too small. It's an assumption that x is very small so that 0.250 minus x can be taken as only 0.250. Now I'm going to plug in the value of Ka, which is 1.0 times 10 raised to power minus 4. Get the value of x. Yes, children, work out the value of x. Like this. Plug in your calculator. I'm getting 5.0 times 10 raised to power minus 3 molar. Are you getting this? Okay. Now I'll check the validity of my approximation. You are learning a new thing, children. All the eyes here. I'm going to tell you a few more things, which is the part of learning. Now here, what is x? The x which you have assumed in the rice table, what is it? It is the amount dissociated. Amount of acid or base, whatever change. It's a change, right? Okay, Dhruv, no problem. Amount of acid dissociated. I'm going to calculate the degree of dissociation or percent of dissociation. To check the validity of my approximation, percent of dissociation. That will be x, the amount dissociated x, divided by HA no, not means initial. Whatever initial concentration of the acid is given times 100%. So please write down this rule, percent dissociation. And what is x in our case? X is 5.0 times 10 raised to the minus 3. And what is the initial concentration in our case? Initial concentration, children? Can you give me the initial concentration from the question? Siri? Sarayu? Last year. Yes, very good. Multiplied by 100%. This is a new formula. There will be question based on this formula also. Times 100%. How much is this? How much you are getting? I'm getting 2.0 times 10 raised to power minus 2. No. Yeah, 2%. Yes. 2%. 100 is also there. Very good string. So what is the percent dissociation here? 2.0%. If this x, the rule is if x, the amount dissociated, is 5% or less, then approximation is valid. Approximation is valid. Is it okay? X, the amount which is dissociated, if this amount is 5% or less than 5%, then approximation is valid. There is no error in approximation. So I think there is no error in our approximation. So our approximation is valid. Okay, now we have the concentration of H plus here. X, we have the concentration of X in molarity. But what is X? Check. What is X? Is the concentration of H plus. H plus is X, see? So what's the pH? Get the pH, children. pH will be negative log of concentration of H plus, which is X. Negative log of 5.0 times 10 raised to the power minus 3, which is 3 minus log 5. And 3 minus log 5 is and I'm going for 3 significant figures because we were using this concentration 0.250. This also should have 3. So answer is, how much is the answer for the pH? Keep checking your answer. 2.301. Yes, Saranya, very good. Sanjana, Saranya, perfect. Okay, so this is the pH. This is how you're going to work out the pH of weak acids. This is a weak acid, nitrous acid. So weak acid, not fully dissociated. Write the reaction, write the rice table, complete the rice table, get the value of X, that X represents H plus, take the negative log of this X value and check your approximation if you are doing approximation. If your approximation is less than 5% of 5, then it's valid. You can use this percent dissociation formula here, this one, the one I gave you earlier. This one, we have question based on it also. Ready for next question? Next question, children. Here. So what was the pH of this HNO2? We calculated it as 2.301. Now the Ka value for this acid is 1.8 times 10 raised to the power minus 5. And it's the same concentration. So approximation is valid here also. Because this one has, if you remember the Ka value here, I gave you 1.0 times 10 raised to a minus 4. This should give me more concentration of H plus because this value is higher. Definitely this is going to give you much lesser by a factor of 10 because this is minus 5. So approximation is valid. So ready for how to do it? What is the first step? Reaction means dissociation of this acid. Acid is this, you can write it like this or like this. So HC2H3O2. Put AQ here, do the dissociation. Yeah, complete the equation, children. Can you write on the equation here? All of you, please write on the equation. The product part, only the product. Give me the product because here this is what we need practice. And then we can make the initial change equilibrium. Yes. Waiting for the answer. Sarayu, what are the products? Ashita? H plus. Where is H plus? Is it right or should I put something? Yes, Vinaya, very good. Very good, Vinaya. Aqueous. Yes, Shri, perfect. Dhruv, check your error. You are not showing me H plus. Then you are not showing negative charge. Okay. Yeah, is it clear to all of you that it's an acid? They have already said it's an acid. So it means H plus is coming out in the water. So when they say acid, right now I'm just doing with acid, but in the examination, it's a mixture of questions. Review classes are very important, children. There you have to identify what is it, acid, base. Then accordingly you will write down the equation. So you have to read the question carefully. You have to identify your compound as acid and then write the equation. Complete the table. I know all of you now know how to complete it. 0.250 H plus is? Yes. Can you show me initial change equilibrium here in the chat? Sanjana? H plus is changes minus x plus x plus x. Equilibrium is all of you make a list of the major species in the solution. I want answer from all of you. So for the major species, you are going to focus on the final situation. This is the final situation, this one. So what all is there finally? And they are the major species. Make the list of the major species. The acid is there, plenty of it. This is undissociated acid, undissociated. Then dissociated is conjugate base. This is the conjugate base, NH plus and water. Yes, these are the major species. Now we need to know pH. And I can use this Ka value. So Ka is 1.8 times 10 raised to power minus 5, which is concentration of H plus times concentration of the conjugate base, acetate ions. These are acetate. This is acetic acid, acetic, divided by concentration of acetic acid, undissociated. Plug in the values. Do the approximation, children. So during approximation, what should I do? Can anyone help me in understanding approximation? What should I do for approximation, children? I want to use approximation. I want to avoid quadratic equation. What should I do? Dhruv, Shrihan, what should I do? Ignore minus x. Yes, Sanjana, very good. Very good, Dhruv. So I'm going to take this value. Only this minus and plus you can ignore. Minus and plus can ignore, not these x's, okay? 0.250. So I'm doing approximation 0.250. I'll check the validity also after calculating x. Get the value of x, children. With units. Give me the value of x with units. I'm getting 2.12 times 10 raised to power minus 3 molar. Are you getting this? Okay, good, good. Very good. Okay, so this is the value of x. Get the percent dissociation. So what's the equation for percent dissociation? I want to check the validity of my approximation. What is the percent dissociation? It is the amount dissociated, which is x, divided by, yes, Sarayu, initial concentration of the acid multiplied by 100%. This is important. So write down this equation. Very soon, on maybe after 2 slides, we'll be doing questions on percent dissociation. Plug in the value of x. Very good, Dhruv. Times 10 is to minus 3 times 100 divided by 0.250. How much is this? 0.848%. Am I right? Yes. Is this approximation valid, children? Is this approximation valid? Yes, it is valid. So this one is your a valid approximation. You have the value of x. You know x, right? Can you get the pH now? pH is, because x is nothing but the concentration of H plus. So pH is negative log of x. How much is this? It will be 3 minus log 2.12, slightly lesser than 3. It is 2.674. 2.674. Okay, check this. Earlier it was 2.301 in this case. Now it is 2.674, slightly higher. It's higher than this. And children, this is pH. It's not slightly. Is 1 degree rise or fall in pH means a factor of 10. If I say pH is 1, pH is 2, the difference is a factor of 10. The concentration of H plus in the first case is 10 raised to power minus 1 molar in this case. And in this case, the concentration of H plus is 10 raised to power minus 2 molar. Can you see the difference is a factor of 10? Because it's a logarithm scale, that's why. Okay, I'm modifying this question and answer the next part of the question. That question is also I have seen. Calculate, I'm modifying the question. Calculate concentration of all major species except water. Water is in excess. Calculate concentration of all major species. You already know your major species. Water is solvent, so leave it. So, do you know the concentration of HC2, H3O2? You can calculate 0.250 minus, you know, X, 2.12 times 10 raised to power minus 3. And you will see you will nearly get 0.250 because this value is too small. Take care of the units. It's concentrations. Molarity. What's the concentration of H plus, children? It's the X value, right? What's the concentration of the conjugate base? See, XX. So these questions are there. Calculate the concentration of all species at the equilibrium. We did these type of questions in unit 7, not with acids and bases, with other substances. So are we clear that how to calculate the pH of weak acids? Write the dissociation of the acid, follow the steps. Dissociation of the acid, then you are going to make rice table. Then if K is given, you can calculate the value of X. X the change, which we were doing earlier also in the rice table. X is also the amount of the acid dissociated. Use approximation. Don't waste your time in using quadratic. Get the value of X. Once you are with the value of X, check your percent dissociation. Check validity of dissociation. If it is 5% or less, your approximation is, sorry, validity of approximation. Your approximation is valid if it is 5% or less. Okay, like in this case, it's less than 5%, right? Over here. So my approximation is perfectly all right, hardly any dissociation. Then get the pH. You can get all equilibrium concentrations because you know X. So if they are asking all equilibrium concentration, that also you can answer. Now, can we do other questions faster than what? Because we were learning on this slide. So let's see other questions. Ready? So I'm going to clear it. Moving to the next question. Okay, read the question and tell me, are you dealing with an acid or a base? Are we dealing with an acid or base? Yes, Vinaya, very good, very fast. Because it is, because it is. Why is it so, Sanjana? Ashita? Because KB is given. Yes, KB is given, that's fine. I already told you that these are bases. Is it a strong base or weak base? Does it fall in the category of strong bases, which you know? No, it's a weak base. Very good. So for the weak base, I need the dissociation of the base in water. Like in acid, I said avoid water. There is no need of writing water. You can work without water. Shriyan, what are you writing? pH of 4? Where is pH given? Is the pH given, Shriyan? Yeah, so why did you write that? Okay, no problem. Okay, so this is a weak base. And for the bases, now again, very important thing which generally you will be struggling in the exam, that whenever they give you this type of base, weak bases of this type or ammonia like this, NH3, you have to write the dissociation in water. Without water, you cannot complete the equation. Without water, you cannot complete the equation. So write water. And then water is the acid. It's a weak acid. This is weak base. Both of them are weak. So can you complete the equation? If by proton donor, proton acceptor, this is proton donor. So write down his conjugate base. What's the conjugate base of water? Water has given H plus. Water has given H plus. H plus has come out of water. Give me the conjugate base. Conjugate base of H2O. Remove H plus. Remember we were discussing earlier? Yes. Conjugate base. Waiting for the answer. Vinaya, Sanjana, Lasya, where are you? Lasya? Yeah, OH minus. So why you people are taking so much time? OH minus. Is it strong conjugate base or weak conjugate base? This OH minus, is it strong or weak? It's a strong conjugate base. What is the reason? Because water, we have said, is a weak acid. Water is weak. It's a weak acid, weak base. Right now it's working like an acid. Okay, this is weak base. Can you write down the conjugate of this weak base? Conjugate acid. Add H plus. Okay, put H with this nitrogen. Don't put it in front. It's okay. If you put it in front, that's also acceptable, but it goes with the nitrogen. Okay. And where is the plus charge? Dhruv, Siri, you're adding H plus. You cannot destroy charges, right? You're adding hydrogen with plus. You must be wondering that why I'm asking you to put it on the nitrogen, because actually, if you make the Lewis dot structure, this nitrogen has a lone pair. Carbon is already saturated. It cannot take anything. It cannot make any bond. So that is the reason we place it on the nitrogen. This lone pair and this H plus combining to give you this. Are we clear about it? About the conjugate acid? Is this conjugate acid strong or weak? This is conjugate acid. Is it strong or weak? You're dealing with a weak base. Weak base will give you strong conjugate acid. People are confused because if you are confused for anything, you can ask questions. Don't hesitate from each other or from me, okay? We are learning. Generally, I've seen that when you're confused, your chat messages, they slow down. Are we confused about how these are created? We practice a lot earlier also. Okay, good, Lasya. Okay, now I'm writing here. So which side of the equilibrium has stronger acids and bases? Which side? The left side or right side? On which side we have stronger acids and bases? Very good. Right side has stronger. So which side of the equilibrium is dominating? In which direction the equilibrium will run? Equilibrium will be more in which direction? To the left. Yes, to the left. Because strongs, they react. Stronger one are reactive, unstable. They react with each other to give you weak acids and weak bases. So equilibrium will run in the direction of weaker components. And weaker components are left side, reactants. Okay, so that's the equation. Very important. So when there is a base like this, you have to write down dissociation of that base in water. You're going to take water as weak acid. Then you should be very careful with their conjugates. Complete the reaction. The dissociation reaction are, now we are going to complete the rice table. Initial, change, equilibrium. You can help me with it. 0.20 molar. This is 0.20, right? And how much is this? Initially 0, 0. Change minus x plus x plus x. Equilibrium 0.20 minus x, x and x. Ka value. Ka or Kb? What should I write? Kb. Let's do the approximation. Same thing what we were doing earlier. So Kb is x squared over 0.20, and that is equal to, the value is given. And we'll check the validity of approximation by using degree of dissociation, percent dissociation. Get the value of x. Get the value of x. Square root. Units will be molarity. See, I'm teaching, I'm doing calculations. Let's see who is going to do faster. Please give me the answer here. All the fingers on the calculator. We are practicing how to use calculator also. Yes, I'm also getting the same. No, I through it is 1.1. Sanjana? Yes, Shrihan is Sanjana are right. So more accurate is 0.011. Dhruv, can you check your value? How come you're getting 10 is to minus 4? You didn't do square root of that? So when you are doing the square root, you have to put everything in parentheses first. Please learn how to use calculator. Start with parentheses, plug in this value, close the parentheses, and then take the square root. Okay, so this is the value of x. But this x is equal to OH minus, concentration of OH minus. So before we go for anything, let's check the validity of the approximation. So for that, I'm going to calculate percent dissociation. Calculate percent dissociation. Percent dissociation is x over the concentration of the base. This time we are dealing with the base, initial concentration times 100%. How much is x? 0.011 was the base initial concentration. 0.20 times 100%. How much we are getting? I'm getting 5.30%. Your approximation is not valid. Are you getting 5.30 children or 5.5? and the approximation is not valid. Now I need a graphing calculator. Then use graphing calculator. Don't do approximation. If approximation is not valid, then you have to plug in this equation. Okay. I'm saying my approximation is not valid. I'm not going to do approximation. So I'll do like this. X squared. Okay, give me 1 second. You can hear me now, children? Hello? Yeah, you can hear me. Okay. Sorry, there was some urgent message. Okay, so it is KB is x squared. So I was telling you that if approximation is not valid, then my equation will remain like this only. But this is a quadratic equation. And for this quadratic equation, I need graphing calculator. That's the reason I'm asking you to practice. You may get this equation. But if you are still in problem with the graphing calculator till last, then you do approximation. Your answer will be slightly different, slightly, which will be acceptable. So I'm still working with the same concentration. Okay, so I'm using this equation because we don't have graphing calculator right now. Now get the POH. This is mathematics, it's not chemistry. Okay, graphing calculator. Graphing calculator is the part of mathematics that you have to learn it from some mathematics teacher, not from chemistry teacher. So what is POH? POH is negative log of concentration of OH minus, right? Plug in the values. Okay, sorry, there is something happened. Just give me a few seconds. Hello. Okay, sorry. Okay, fine. So negative log of OH minus, and then you have to plug in the concentration of OH minus here, negative log 0.011, and get the POH. How much is the POH? And get it for two significant figures, Sanjana. So 1.96. Is this answer right? Sanjana is giving us this POH. Now get the pH. If this answer is right, get the pH because they are asking pH. They are not asking POH. So take care for the basis. You are working with OH minus, you are calculating POH, and then you are converting that POH to pH. Yes, very good. 12.04. Perfect. Are we clear how to use a rice table to calculate the pH of a weak base? How to check the validity of the approximation? And if approximation validity is not within the limits, what are the limits? Limits are that it should be 5% or less. But in our case, it's slightly more than 5, so still valid. Because if we are struggling with the graphing calculator till last, then you do approximation. You're not going to lose many marks, or maybe they will not take off your marks. Okay. Now I'm coming on the next question. Check this one. Now we are going to do different varieties of questions based on rice table. Okay, Dhruv, thank you very much. Check this one, children. The pH of 0.063 molar hypobromous acid is an acid. No, Shrihan, I don't think. Quadratic equation I also know how to solve. Can I show you how to solve quadratic equations on the calculator using math button? Okay, now you can see the math button there. Math mode, right, Shrihan? Okay. Can we do few questions? And before ending the class, 10 minutes before ending the class, we can work on it. So, children, we have dropped the idea of taking extra 30 minutes class. From next week, we are going for extra classes. So, next week will be very tough for you, next weekend. So, come prepared for it. And we'll try to cover maximum next weekend so that we can start our review classes well in advance. Okay. So, Shrihan, just before ending the class, I'll request you to do that. Okay. So, ready for this question, children? pH of 0.063 molar. It's an acid, you can see. You have to read the question carefully. They have given the pH. They are asking Ka. So, if pH is given, pH is 4.95. What's the concentration of H plus then? You remember the equation? 10 raised to power minus pH. That is 10 raised to power minus 4.95 units molar. I'm leaving it like this, molar. Okay, it's a weak acid. You can see HBRO, hypobromous acid, HOBr or HBRO. It's the same thing. Hypobromous acid. I told you that all the acids ending with us in the nomenclature, they are weak acids. So this hypobromous acid is weak acid. So it means I have to deal with the rice table. I'm going to make the rice table, children. It's an acid, so there is no need of writing water. You can make the dissociation of the acid. What is the conjugate base? All of you, please type the conjugate base of this hypobromous acid. This hypobromous acid. Uh, Shriyan, you have joined the class twice. OBr minus. Shriyan, you have joined the class twice. Very good. OBr minus. Now complete the rice table. And what is HOBr? Initial concentration 0.063. How much H plus initially? 0, 0. The change minus X plus X plus X. Equilibrium 0.063 minus X, X, X. They're asking you to calculate Ka. Do you know X? Children, Shrihan, do you know X? Yes, Sanjana? Yes, we know X. See, H plus is X. I know H plus. pH is given. So X is 10 raised to power minus 4.95. So what is Ka? Ka is X squared, this times this, X times X divided by 0.063 minus X. I know X, 10 raised to power minus 4.95 squared. X squared, right? Divided by 0.063 minus 10 raised to power minus 4.95. Put it in parentheses. Now, when you're going to plug in this in your calculator, now listen to me carefully. Don't give me wrong answers. Start with parentheses, plug in this value, close the parentheses, take the square of that raised to power 2. Then put the division mark, division, press division, and then start parentheses again, 0.063 minus 10 raised to power minus 4.95 and close the parentheses and then enter. Check what are you getting. This is how you have to solve. You have to go step by step in the calculator also. Nothing random here. Anyone with the answer? I'm with the answer. Yes, Siri, I'm also getting the same. In fact, when we do the approximation, is it after approximation, after dropping the next digit? Because I'm getting 2.00. Yeah, so use the approximation rules, dear. Then it is 2.00, three significant, no, two significant figures. 2, 2, 2.0 times 10 raised to power minus 9. You know, Ashita, what you children are doing? It is 1.9986. You want to drop this 86, so you have to add 1, isn't it? Nasia, Siri, you have to add 1 here, correct? Okay. So please round off. You remember the rules for rounding off? So this is the answer. Any units? This is Ka. Any units? No units, no units. Okay. So can you see that here pH is given, initial concentration is given, and you are calculating Ka. Saranya Sarayu. I cannot see your name here in the chat. Saranya and Sarayu, please solve with me, okay? Sarayu, keep practicing your calculator. Okay, degree of dissociation of acids and bases. What's the formula? I discussed the formula, you remember when we were checking the validity of the approximation? So, for degree of dissociation, it's not percent, it's degree. Degree of dissociation, it is X, the amount dissociated. You remember amount, the change, amount dissociated in the rice table? X is the amount undergoing dissociation over initial concentration of the acid or the base times 100%, right? Times 100%. That's the degree of dissociation. And what is the percent of dissociation? Percent of, oh, I think I've written 100% here. It should not be 100%, it's degree. Percent dissociation, You can say X, the amount dissociated, initial concentration multiplied by 100%. So generally we are working with this equation. We have done this already. Now we are going to use this particular equation in a question. Let's do it. Can you see this question? 3% dissociated. This is initial. They are asking you to calculate Ka. Anyone can, it's a mathematics. It's the same. I have already given you all the equations. You know it's a weak acid. It's written here, weak acid. So you know that you have to make the rice table to calculate Ka. In the rice table, you need to know the value of X, the amount dissociated. Then mathematically you can use this equation to know the value of X. And then plug in the rice table, get the value of Ka. Okay, children, tell me the plans. Who is going to help me? What should I do first? What should I do first? I can use this. I know that percent dissociation is X over initial concentration of the acid. If acid is not given, like here, they have not given us any formula, then you can assume Ha times 100%, which is 3%, 3.0%. This percent cancelled. So X divided by, this is given, 0.15. Srayu, you are listening? Is 3.0. So what is X? 3.0 times 0.15 over 100. How much is this, Dhruv? I think it is 4.5 times 10 raised to power minus 3 units molar. X is the concentration which has dissociated in the rice table. Is this answer correct for X? So what we are doing, Sanjana? We are calculating value of X from the percent dissociation and initial concentration by using this equation. It's just mathematics, right? Now, what should I do next? What's the aim? Aim is to calculate Ka, this Ka. For that, I need rice table. For the rice table, I need to see the reaction for the dissociation of this weak acid. Weak acid, you can always assume as Ha. It's a weak acid, so there is an equilibrium. It's going to dissociate as H plus aqueous plus A minus aqueous, right? Then initial change equilibrium. Initial given? Yes, it's given here, this one. Rice table we know how to make. So I'm making it very fast. Now, do you know X? Yes, I know X. See? So what is Ka? Is the concentration of H plus, concentration of A minus over concentration of He. H plus is X, A minus is x over HA, that is 0.15 minus x. Plug in this x here, this x, and you will get the value of Ka. So it is 4.5 times 10 raised to power minus 3 squared over 0.15 minus 4.5 times 10 raised to power minus 3. So again take care. Start with parenthesis. Plug in this value. Close the parenthesis. Raise to power 2. Press division. Start with parenthesis. 0.15 minus whatever is there in the denominator should come in the parenthesis. Close the parenthesis. Enter. You will get the answer. How much you are getting, children? I have solved it. Give the answer up to two significant figures. 2 here, 2 here. So answer will be in 2. Are you getting 1.4 times 10 raised to power minus 4? Is this the answer? I'm not sure about my answer, okay? So don't think that I've given you the right answer. You have to confirm, is it right or wrong? Okay, I did twice and I'm getting the same answer. No, Shrihan, it's not minus 6. I'm not getting minus 6, Shrihan. Yes, anyone else? Shrihan is giving me minus 6. I'm saying minus 4. Anyone else doing calculation? Dhruv? Sanjana? Nasya? Sanjana has confirmed. It's my answer. Vinaya? Okay, good, Vinaya. Okay. Okay, Lasya. Good. And it's a Ka value, no units. So can you see that different varieties of questions can be there? Like in the previous question, pH was given. They were asking Ka. Now percent dissociation is given. In the answer, okay, Shrihan is asking a question how to read e raised to power minus 6. I think you are going to read it 10 raised to power minus 6. So you have done some error in plugging in the values. Okay. Maybe you have not placed the parenthesis in the right way. Because if you miss these parentheses, you will not get the right answer. So different varieties of questions can be there. Like it here, the pH was given, asking Ka. Over here, percent dissociation is given and asking Ka. Ready for this question, children? So what are they asking here? The percentage of pyridine undergoing dissociation. And here everything is given to you. They have said assay Is it a base or acid? Can you identify? Is this a base or acid? Children, is it a base or acid? It's a base. Kb is given. Sarayu, Kb is given. So look at the Kb value. Is it a weak base or strong base? It's a weak base. Kb is very small, less than 1. And when these values are 10 raised to power minus 5 or less, then remember approximations are always valid. Okay, no problem, Lassia. Approximations are always valid when the Kb or Ka value are 10 raised to power minus 5 or less. They are valid. Remember that. So no quadratic equation. So here, how to start? Anyone? C5H5N is a base. So I told you that if it is a base, you cannot write down the dissociation without water. It's compulsory to have water there. Now they have already given you the conjugate acid. See? Pyridinium ion. The conjugate acid is given. What else is here? Can you complete this blank, children? This is the conjugate acid of this base. Water is weak acid. So what's the conjugate of water? Yes, very good, Sanjana. Perfect. OH minus. Yes, Ashita. Good. Okay. Both of them are weak. Can you see? It's very weak. Very, very weak. It's a weak base. It's a weak acid. This is a strong conjugate acid. This is a strong conjugate base. So equilibrium will be dominated by the products or the reactants. Equilibrium will be dominated by reactants. Shriyan, why products? Products are stronger. As it is, you look at the Kb value. Kb value is less than 1. Here, the equilibrium constant K, which we are calling it as Kb, is less than 1. Very, very less. If Kb is less than 1, then reactants are dominating. Okay, so these are very simple question, multiple choice type. Okay, now this is the reaction, the dissociation, initial, change, equilibrium. Initial concentration is given to you, 0.10, right? Water, we are not interested because it's not the part of my Kb. This is 0, 0, minus x, plus x, plus x, 0.10, minus x, x, x. What is Kb, children? Can I do approximation? Yes, you can do approximation. This can be taken as 0.10. So what is Kb? Kb is the concentration of pyridinium ion times the concentration of OH minus over the pyridine. So don't worry about the names. I'm reading. You can read the names given here. Pyridine, pyridinium ion. Plug in these equilibrium concentrations, equilibrium. X squared over 0.10. Kb is given to us 1.7 times 10 raised to power minus 9. Get the value of x. Again, be careful with your calculator. 0.10. Take the square root of this number because this is squared, right? Yes, what is x? Ashita, can you give me the value? Fast, very fast. I think I'm getting it. See, I'm faster than all of you. Let's check whether I'm right or wrong. Yes. And Sanjana is more right than me. Saranya and Sanjana. Why? Because they have taken the correct significant figures. And I ignored the significant figures, so I'm going to replace this zero. This is the right answer. Units? Yes, there are units. Molar. Now let's answer this part. Percentage of pyridine which has dissociated. So percent dissociation, right? So the percent dissociation is X divided by the initial concentration multiplied by 100%. So what is X? Initial times 100. Is this the answer, children? Like here, I'm not using calculator at all. Yeah. So you can see that your approximation is valid. It's less than 5%. So you can check the that approximation validity also. Yes, Saranya, very good. With the correct units, she is giving us with the correct unit, percent. Can you calculate the pH, children? Calculate the pH. Mhm. pH is negative log of H plus, but H plus is not given to us. What is given in this rice table? OH minus is a base. So we have OH minus. And the concentration of OH minus, you know, how much is that? 1.3 times 10 raised to power minus 5 molar. So you can calculate the pOH, get the pOH and get the pH. So I'm waiting for the answer. For the pOH, first type the pOH and then pH. Sarayu, get the pOH. So this is a base, so you're getting OH minus. Okay. Shri has already given us the pH. Okay, rest all are giving me pOH. Okay, good. So what's the pH then? Now pH? Yes, 9.11. Yes. So pOH is 4.89. So remember this thing. I have seen children doing error in the examination under pressure that even for the base, they have the OH minus, they take the negative log of that OH minus and they write it as pH. But that's the pOH, right? Negative log of OH minus is pOH. So get the pH. In the solution you can see is basic, more than 7. pH is more than 7. So we are good with this. I'm going to clear it. So you can see the varieties of questions. Now we are on the next topic. Now all of you please be prepared for plenty and plenty of questions. I will not move till the time you don't answer all the question what I'm asking. Okay, we are going to learn this here only. It's very simple thing. Do you remember how to calculate oxidation numbers? How to calculate oxidation numbers? Like for example, if I give you SO4 2 minus, and if I ask you to calculate the oxidation number of sulfur, you remember the rules, how to assign oxidation number? You're going to take sulfur as X, then you're going to say 4 times oxygen is minus 2. Generally, it is minus 2. Generally means 99.9% is minus 2 as oxide. The sum of all the oxidation number is equal to minus 2. So what is X? Yes, Shrihan, what is X, Sanjana? X is plus 6. Generally, I write oxidation number with plus and minus. Okay, so don't write without plus minus. Okay, can you calculate the oxidation number of chlorine in ClO4 minus? Okay, calculate the oxidation number of chlorine. You can say this chlorine is, yeah, X plus 4 times minus 2 is minus 1. So Vinaya is perfectly correct. Shrihan, I said right plus, okay. Now tell me, which atom, the one with plus 6, the one with plus 7, which atom is more electron hungry? Which atom? So Dhruv, why you're saying sulfur? Which one has more positive charge on its head? Dhruv. Yeah, good. It's chlorine. So more electron hungry means more electronegative. Can I say that? It's going to pull electron density more strongly on itself. So when I'm going to compare the strength of oxo acids, oxo means oxygen containing acids. These rules are for oxo acids. It means for non-oxo acids, I'm going to give you different rules for oxo acids. So what are the rules? Very simple topic, children. All of you can learn it. The first rule is that compare the oxidation numbers. So calculate the oxidation number. Second, if oxidation numbers are same, then you can compare the electronegativity using the periodic table of of the central atom. This is the rule. There is no other rule for oxygen containing. So before we start practicing these rules, we need to understand where is acidic hydrogen. In oxo acids, whatever acid you take, you can draw the Lewis dot structures of these acids. In oxo acids, acidic hydrogen is on the oxygen. Always, whatever is the central element, it doesn't matter. Acidic hydrogen is on the oxygen. Like for example, if I say HNO3, hydrogen, by that rule that in acids hydrogens are written in front, that's why it is written in front. But it does not mean that it is on nitrogen. No, it is not on nitrogen. Where it is? On the oxygen. It's always like this. Here is your central element. So what is the central element here? Nitrogen. Where is this hydrogen? On the oxygen. Check the Lewis-Dot structure. Lewis-Dot structure, children. Unit 2. Where is acidic hydrogen? Where is acidic hydrogen? On the oxygen. Remember, this is very important. If I give you H2SO4, check. Central element, sulfur. There are 4 oxygens because hydrogens are not on sulfur. That's what I said. Acidic hydrogen is on the oxygen. So these hydrogens are not on sulfur. Where are they? They are on the oxygen. Okay. It's tetrahedral. So let me make it tetrahedral. It's going to be tetrahedral because it has 4 groups around it. Like this. Can you see your acidic hydrogens? So this is very important to understand that in oxygen containing acids, sulfuric acid, nitric acid, perchloric, chlorus, hypochlorous, nitrous, all oxygen containing acids, they have their hydrogen on the oxygen. Okay, now I'm going to compare the acidic strength based on oxidation numbers and electronegativity. Okay, check the oxidation number of this nitrogen. Yeah, who is going to tell me the oxidation number here? Remember, hydrogen is +1 when bonded to non-metals. Oxygen is -2. This oxygen -2. This oxygen -2. This I can assume as X. The sum of all oxidation number in HNO3 should be 0. There is no charge. These charges cancelled. This plus and minus cancelled. These are formal charges. So it is X +1, this +1, -2, -2, -2 is 0. So what is X? +5. So nitrogen here is +5, which you can calculate by using simple, looking at the formula here. You need not to draw the Lewis-Dot structure for acids all the time. This I am making you just to make you understand that your acidic hydrogen is here. Like here you can say this +1 hydrogen. Nitrogen is X. There are 3 oxygen with -2 is 0. So X is +5. Yes, Shriyan, good. Yes, children. Can you work out the oxidation number, Sarayu? This is very important for unit 9 also. Get the oxidation number of this sulfur. This we did in unit 4. Get the oxidation number of sulfur. Mhm. Yes, +6. Now tell me, which one has higher oxidation number here, sulfur or nitrogen? So which one is going to be stronger acid? The one with high oxidation number. Write down this rule. High electronegativity, high oxidation number. If these values are high, then is stronger acid. Stronger acid. And understand the reason. This is something which is really, really important. And really struggling with my organic students because they are unable to understand this because the base is missing. I don't want my students, like all of you are my students now, I don't want you to be so much confused with your organic later on if you are planning to take. Okay. So make your base strong. It's not for AP only that you have to appear for AP exam. It's for any chemistry exam or if you want to learn chemistry later on. It's important. All the things. Very, very important. Now let's try to understand why. Why is this so? Why I'm saying that if it is high oxidation number, like here it is +6, here it is +5. So the one with high oxidation number is more electron hungry, right? So it's going to pull this electron density like this. This one is also going to pull electron density from the sulfur is going to pull from this oxygen, from this oxygen. So what happens? Oxygen will try to pull the electron density from the hydrogen like this. So due to this pulling effect by this sulfur, hydrogen is left without electron density and hydrogen will find it easy to come out as H plus. Sulfur is pulling electron density from the oxygen, oxygen is pulling electron density from the hydrogen, and then hydrogen is coming out as H plus. And this release of H plus, release means donating, coming out, release of H plus means acidic. If it is faster, if it is easy to donate H plus, then it is stronger acid. So this one is stronger acid because this sulfur has very strong tendency to pull electron density from the oxygen. So the release of H plus is faster. So it's stronger. Are you getting it? So high electronegativity means more tendency to pull electron density. High oxidation number means more tendency to pull electron density. So that element, central element, we are comparing central. That element can pull electron density from the oxygen. Oxygen is going to pull electron density from the hydrogen and hydrogen can come out easily as H plus. Is it okay? Sarayu, you have understood this? Sarayu, I have to call your name. I cannot see your name here, dear. Sarayu, you have to answer the question, okay? Ready for questions now? This is the reasoning that what is the reason, explanation, why? Because more electronegative atom and high oxidation number will pull the electron density from the oxygen. Oxygen will pull the electron density from the hydrogen, making release of this hydrogen faster, means making it stronger acid. Okay, now we are with the questions. So what are you going to compare? Electronegativity and oxidation numbers. If these two are high, high means stronger acid. Simple rule. Just you have to keep these things in your head. Now, HClO4, HClO3, HClO2, HClO. Compare the acidity. Now, chlorine is same. Chlorine, central element, chlorine, you know this hydrogen is on the oxygen. Central element, chlorine, in all of them. Where is hydrogen, children? Where is hydrogen? On the oxygen. Okay, just calculate the oxidation number because electronegativity I cannot compare. Same oxidation number. Get the oxidation number. Electronegativity, chlorine, 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 chlorine. So I cannot compare. What I'm going to compare? Oxidation number, right? If you look at the periodic table, they all are chlorine. So get the oxidation number. Yes, what is here? Yes, all of you. Oxidation number, children, of chlorine. Yes, Vinaya, very good. Plus 7. What is here? What is here? Yes. What is here? You need not to calculate for rest. You can see that here it has 4 oxygen, here it has 3 oxygen, 2 oxygen, 1 oxygen. Yes, Shriyan, he has observed the trend. As you remove 1 oxygen, oxidation number decreases by 2. 4 to 3, 7 to 5. 3 to 2, 5 to 3. 2 to 1, 3 to 1, like this. Okay, so which one has the highest tendency to pull electron density here? Which one has the highest tendency to pull electron density from the oxygen? This one, plus 7, very electron hungry. So this is the strongest acid. So this is the order of acidity. Can you write down their conjugate, children? Sarayo, I cannot see your answers again. Can you write down the conjugates? Conjugate of this. What is the conjugate of HClO4? ClO4 minus. Conjugate of this. ClO3 minus. Conjugate of this. ClO2 minus. Conjugate of this. ClO minus. Now, can you arrange these conjugates on their basic strength? This is the strength of the acid. These are the conjugate bases. A stronger acid will give you, this is strongest here. A strongest acid will give you weakest conjugate base. Remember this? Strong acid will give you weak conjugate base. Weak acid will give you strong conjugate base. Remember this line? So a stronger acid will give you weakest. This is weakest. This one. Order is this. This is the weakest acid. Weakest acid. See here. So the conjugate is strongest. So which one is the strongest conjugate base here? ClO minus. You already know the name. If you don't know, then please pull out your polyatomic ion list. Hypochlorite. Hypochlorite is very strong conjugate base. So with the strength of the oxo acids, you can compare the strength of their conjugates also. Ready for another question? Another question, children. All of you, try to answer. HiO4, HClO4. So I'm going to compare the electronegativity and I'm going to compare the oxidation numbers. So central element, iodine and chlorine. Which one is more electronegative, iodine or chlorine? Look at the periodic table. Chlorine is more electronegative. Very good. And what is the oxidation number of these two? Calculate the oxidation number. Chlorine is more electronegative than iodine. Oxidation number is +7. So I'm not going to compare the oxidation number. I'll decide from electronegativity. So which one is stronger acid? Which one is stronger acid? Yes, this is stronger acid. Give me their conjugates, children. The conjugate of HiO4 is IO4 1 minus. And this one is ClO4 1 minus. Which conjugate base is stronger? Which conjugate base is stronger? Only Vinaya is right. Why you are saying that? This is strong acid. This is stronger than this. A strong acid will give you weak conjugate base. This is weaker. So Vinaya was right. Yes, Lasya. You're understanding this? How to compare? Don't do error like this. A stronger acid will give you weaker conjugate base. So this is stronger acid. Its conjugate base will be weaker than this one. Another question. H2SO4 and H2SO3 oxo acids. I'm going to compare electronegativity and oxidation number. Which one is stronger? Can I compare electronegativity? No, because both of them are sulfur. This is sulfur. This is sulfur. So I cannot compare electronegativity. So I will calculate oxidation number. Work with oxidation number. Mhm. Work with oxidation number, children. What's the oxidation number here and here? Yeah, +6. One oxygen less. So I'm expecting this should be +4. So which one is stronger acid? Yes, this is stronger acid. Write their conjugates. Remove only one hydrogen. You can see here it has two hydrogen. It's diprotic acid. Diprotic. Diprotic acid. Yeah, the conjugate of this one is HSO4 minus. And the conjugate of this one is HSO3 minus. Which one is stronger base? Which conjugate is stronger? Yes, Sanjana, very good. Very good, very fast. Yes, because weak acid will give you strong conjugate base. Are you getting the meaning of diprotic acid, children? Diprotic? Diprotic means an acid which has two acidic hydrogens, 2H plus. What can be monoprotic acid? Monoprotic. Monoprotic acid. The one who can give only one H plus, one acidic hydrogen. Yes, Sanjana. Can you give me example of monoprotic acid, children? We were doing plenty of them. Give me example of monoprotic acid. Mhm. Yes, HNO3, HCl, HBr, all these are monoprotic. HClO4. perchloric acid, HClO3, all these are monoprotic acids, right? Do you know any triprotic acid? Triprotic. Maximum we can have triprotic. Very popular acid. This is the part of our biological system also. Triprotic acid. Anyone? You people are weak with your polyatomic ions. H3PO4. Yes, Shrihan. Phosphoric acid. In the biochemistry books, you can see this acid written as Pi. They write it as Pi. Okay, that is triprotic. Okay, so now let's take a triprotic acid, H3PO4. Let's compare it with another triprotic acid, H3ASO4. Tell me, which one is stronger? These are triprotic acids. Compare electronegativity, compare oxidation number. So let's start with electronegativity. I can compare. Let me finish with this, Saranya. Compare electronegativity, children. Who is more electronegative? Look at the periodic table. Which one is more electronegative? Check nitrogen family. Nitrogen family. Nitrogen, phosphorus, arsenic, down the group. Which one is more electronegative? P. Now, P is more electronegative than arsenic. That is clear. Now, check the oxidation numbers also. What is the oxidation number of P here? And AS here? Yeah, +5. +5. So, who is more stronger acid? Which one is stronger acid? Yes. Can you give me the conjugate bases after removal of one proton? Remove only one proton. Conjugate bases. Yes, this one is H2PO4, 1 minus. And this one is H2ASO4, 1 minus. Which one is stronger? This one, right? This one? Because this is weaker acid than this. Can you make the another conjugate of this? Because there are two more hydrogen. Make the another conjugate, a conjugate base. Remove one more proton. All of you, please try to answer this. Remove one more proton. HPO4, still wrong, Saranya. 2 minus. Yes, who is this? Sanjana. Very good. You remove one more H plus, so one more negative. Sarayu, take care of charges. We are practicing to understand charges, right, Sarayu? Now remove one more proton, Sarayu. Remove one more H plus. Make another conjugate. Yes, PO4. Now 3 minus. Yes, like this. Like this. No, no. No hydrogen, Sanjana. There was only one hydrogen. I removed that. Okay, so you can, for the diprotic, triprotic, you can keep removing protons. First proton, second proton, third proton, like this. We'll discuss more about it. Now I think I can hand over this to Shrihan. Shrihan, you are ready to teach us? Shrihan. Okay, okay. Children stay in the class because everybody has problem with the. It's very nice of him that he's giving us this option. We should be thankful to him. Okay. Second. Share the. Yeah, Shriyan, yes, you can talk. You can share video and you can talk. Children, you can see the video? Light from your background is giving us a reflection, Shrihan. There is a light in your background. Yeah, this light. Okay, and you unmute yourself. Okay. Mhm.
Hello.
Yeah, we can hear you.
Hi.
Okay, children,
So,
he's trying his best to show us.
oh
So
yeah.
please, yeah, start.
So, what you want to do is click the math button. Oh, whoops. Click the math button. Then go down to numeric solver, and then enter your like equation here. You can enter 2 if you want to solve for like systems. So, like there. And then after you enter your equation here, you click the graph button, and then you can find the x values.
Okay.
Yeah.
I think Dhruv is asking a question, Shrihan. Which number in math?
Oh,
Okay, children, I think you write down steps, all of you. Then you can practice in your calculator. Shrihan, can you tell us from the starting all the steps? From the starting.
okay. So you go to math. You click the math button here. This is for TI-84 plus CE. So you click the math button, and then you go all the way down. The number it's C. It's a letter because it's all the way down there. And then
Hmm.
you click enter, and then like right now I don't think it's showing because the light, but oh, it doesn't exist.
Maybe you
Okay.
have done some error with the sign. So try it again.
Wait, I did what?
Maybe some error with the equation because you said that you are getting answer doesn't exist, right?
No, no, I was talking about do statement. Yeah, my answer does exist.
Okay, okay, okay.
Yeah, so once you enter your equation on the top box here, like this top box, you press graph, and then you're going to get your x value.
Okay. Now, Shrihan, can you tell me the steps? Like first I press the math button. After that,
Yeah, let me go back.
go slow. I'm typing here.
Okay,
Math
so
button.
yeah, math button. Then if you have a TIA 4 plus CE,
Mm-hmm.
yeah, it's
Then,
the numeric solver.
okay,
So you go down to yeah, numeric solver. It's at the like really bottom of the math functions. Then
mm-hmm.
you press enter. Yeah, you press enter after you're on there, and
Yeah,
then you click. You enter your equation on the top box here, like the one that says like E1, and you don't have to like make you don't have to make it like equal to 0. You can make it equal to whatever. But if you like don't put an equals mark, it like uh it makes it equal to 0, and it solves for x. And
okay.
once you enter it on the top box, you click graph, and then you'll get the x value. So here it's -5.
I think these are the steps which Shriyan gave us. Math button, then go
Yeah,
to numeric solver, enter your equation, put it equal to 0, then click graph. So Shriyan, am I right?
Yeah, but you don't need to make it equal to 0. You can just enter like the expression.
Okay, but if we put it equal to 0, will there be any error? No.
No, no, no.
Okay, okay, great. So that's really good, so simple. And we were struggling with it. So next time we are going to use it, all of us. Is it clear to all of us? Shrihan, can you come in my another group also? Group 2 for few minutes.
Uh, sure, I guess. Yeah,
Okay, okay. I'll give you an invite just for few minutes in the starting of the class, whatever time is comfortable for you. You can join at that time. I'll share the link
okay,
with you and just show this to them also because they are also struggling with it. And it's so
sure.
simple. Okay, children, is it clear to all of you?
Drew says that he can't use it because of the older version.
Which one is
I
the
don't.
older version? It's the method will be the same, Dhruv. You have to see that math mode. Maybe some language may be slightly different. Dhruv, so try to, s- because the main method will be the same.
And also, yeah, I think it on old. Yeah, I think on old one you scroll down to it's called solver. It's not numerical solver.
Yes,
It's just solver for TI-84,
yes.
not for plus.
So, can you type the name of the calculator here?
Oh
TI
yeah, sure.
84.
For TI-84, you go down to solver,
Okay.
but for TI-84 plus, you do what I did.
Can you type the name of your calculator?
Sure.
Okay. So I think I told you this name only in the starting when we started the classes that purchase this latest one. It's going to help you in your college also. Okay, in the colleges, calculators are permitted in every exam. So it's not a waste of money. You can carry on this for the next 4 5 years. So thank you very much, Rihan. It's very nice of you. Very
Yeah, no problem.
impressive. You're a good teacher. Okay, so
Thanks.
see you in the next class. So next Saturday morning there is a class. Those who cannot attend it, please watch the video before Saturday evening class. So I'll ensure that I'll post the video before I go to sleep because it will be my night. So after finishing the class, I'll post the video. Then you watch it during your daytime and be ready for your evening class. Message is there on WhatsApp, Siri. It is, you are on which time zone, Siri? EST. Then it is at your 10 a.m. Oh, sorry. 10 a.m. for EST. Those who are unable to attend, please try to understand that if we do some extra classes, we can manage the syllabus very well. And you can ask your difficulties. Generally, I'm asking you to stay back in the class. After finishing the class, I'm there for 15 20 minutes. So you can ask your difficulties at that time. So see you in the next class, children. See you then. Bye bye. Bye. Thank you, Shrihan. Thanks a lot.
Hello.
Yes.
Where will you send me the Zoom link for your next class?
Yes, I will send you the Zoom link. Yes.
Okay.
Okay. Thank you very much. It is
Yeah,
on
no problem.
Tuesday, your Tuesday.
Oh, Tuesday, what time?
Tuesday in the night around,
Uh,
you're in which time zone?
PST.
PST. So maybe it is around your 6, something like that.
Oh, I have a class from like 5:30 to 7 on Tuesday.
Oh, so I'll call you at 7 then.
I'll get home
7,
at like around 7:30.
7:30. Okay, 7:30. to 7. Yeah, I think they will be there. I'll ask them to stay back. If they want to learn, they have to stay back. Okay?
Sure. Might be like a few minutes late, but like yeah, 7:30. I'll probably
Yeah,
be there.
yeah, sure. Yeah. Okay then.
Okay.
Thank you
Thank
very
you.
much. Thank you.
Yeah.
Bye.
Thank you. Bye.
Bye.